Measurement is really at the heart of all mechatronic systems. In order for the mechatronic system to take appropriate action in its environment, it really needs to understand the current state that it's in, and what it's seeing perhaps in its environment. In order to make a measurement, you need to answer several key questions. So the first step of any measurement is you're going to be determining the objectives and measuring any key variables. First question for that is what you're trying to answer with this particular measurement. A second question would be what needs to be measured in order to answer those questions. And a third question would be on what variables are going to affect the results. It's important to point out here that there are several different types of variables that you might have to deal with in a measurement system. The first, of course, are independent variables, and these can be changed without affecting other variables. Second would be dependent variables, and these will affect other variables. And then a third type of variable would be an extraneous variable. And these are variables that either aren't or can't be controlled during the measurement, so something like the weather. Now, a second subset of questions when you're trying to take a measurement will fall around the idea of the system and measurement design. System and tolerance design. So, related to the system, these are questions like how can I perform the measurement? And related to tolerance, how good the results need to be. And then a final set of questions is going to be around the data that you actually collect from your measurements. So these will include how you interpret the results, how good the answer is, and a very important question of does the answer actually make sense? So this is a bit of a wall of text, but really the idea is to present questions that you want to be asking as you're designing your sensor system in your mechatronic system in order to make these measurements and do so in a way that's appropriate for whatever application you're actually trying to accomplish. So let's go through a quick example of that with gas mileage. So the question that we're trying to answer in this case is what is the gas mileage in my car? Right? In order to answer that question, I need to figure out what needs to be measured. And in this case, if I'm trying to measure gas mileage, I'm going to have some idea of the fuel that's consumed and the distance that I travel in which that fuel is consumed. So these are the two things that I'm going to need to measure in order to answer my question. So if I think about what variables can ultimately affect the result, this is going to be a really long list. So things like the type of fuel, city or highway driving, road surface, tire pressure, the type of the car that I'm driving, speed, my general driving style, do I have a lead foot, weather, if it's raining, if it's snowing, right? All of these things are going to affect the fuel consumed and the distance traveled and ultimately the gas mileage that I measure. If I'm thinking of the type of variables that these things might be, type of fuel, for example, can be an independent variable. Something like the road surface would be a nice dependent variable. Other things are going to be affected by the road surface, like the speed that I'm driving at and my driving style, perhaps. And something like weather is an extraneous variable, something that I'm not going to control. I can't physically control during my study or during my measurement. So back to the relevant question of what needs to be measured. How can I actually perform these measurements, or how can I actually measure these variables? Well, if I'm looking at the miles traveled version, I can think lots of different things that I could use for this. GPS, the odometer, an average speed that I'm traveling, plus a stopwatch. There's lots of different methods, I imagine, that you can think of here. In order to measure fuel consumed, I might be able to measure the mass of the fuel rate over time, the volume of fuel that's consumed. Once again, lots of different ways that I could actually measure this variable. And if I think about how I'm designing the kind of tolerance of this system, I really need to answer the question of how good my results need to be. Obviously, this is going to have a lot of implications in terms of the actual sensors that I choose to make these measurements. So if I need something that's very precise, down to millimeters, GPS wouldn't cut something like that, right? If I need to measure the amount of fuel consumed, fuel rate over time might be a nice accurate measure of that, whereas just kind of a geometry estimate with volume might not be so great. So for example, if I'm just doing this for curiosity's sake, maybe I need something in the range of plus or minus 1 mile per gallon. If I'm doing this for CAFE standards, then I need this down to plus or minus 0.1 mile per gallon, right? So depending on what you're actually trying to make the measurement for, you might have different tolerances, and you might have to make different choices in your sensing system in order to accomplish that. Now, to answer some of the data questions, like how good is my data, you might want to actually do some replication or repetition of experiments or measurements in order to be able to answer that question. Replication is going to be duplicating measurements under the same operating conditions. In contrast, repetition would be repeated measurements during the same test. So this might be measuring a fuel mass while the car is standing still with static. Now these, along with any kind of noise or interference you might have from extraneous variables in your experiment, are going to be answering the question of how good is the data. Of course, you're not necessarily going to want to do these all the time because there's going to be some time and cost associated with replication of measurements or with repeating measurements many times in order to remove effects of noise and interference. So there's obviously always going to be this delicate balance as to what makes sense for your application. Now, in order to answer the question of if the measurement actually makes sense, your measured value, if it actually makes sense, we're going to use concomitant methods. Now, it's just a fancy word for using a different technique to do the same measurement. And once again, that's answering the question of does the measurement make sense? And so as we were talking about with distance traveled, I might be able to do that using my odometer, might be able to use that using GPS, and those would be two independent methods of getting the same data of distance traveled. And so those would be concomitant methods in order to measure the miles traveled.